Hello friends, my name is Dr. Sunil Kumar Jata. Today I will discuss the phases present in the iron cementite phase diagram. In the previous lecture we have discussed about the iron cementite diagram, iron carbon phase diagram. So you are welcome in my channel Meta Engineering. So already we have discussed in the previous lecture about the iron cementite phase diagram. We also draw the diagram, and today we will discuss how many phases are present, and the phases are present that will be the described. So here many phases are present like delta ferrites, austenite, delta ferrite, alpha ferrite, austenite, and the cementites. So these phases are the equilibrium phases, and some other phases also present in the steel like vanite, martensite, but that are not equilibrium phase. That are the non-equilibrium phases. So alpha ferrites is found at the low temperatures from the room temperature to up to the room temperature to 910 degrees centigrade. Then austenites is formed, and at the higher temperature delta ferrite is formed. So perlite is also formed, but perlite is the micro constituents, and which is present 100% in the 100% in the uh, 0.77% or 0.08% carbon. Mostly in these phases like delta ferrite, alpha ferrites, and austenite, cementites, we will discuss in today lecture. We will discuss in today lecture and with some features and properties and their microstructures and how the carbon percentage is present in these phases. So first we will start from the alpha ferrites. So alpha ferrite. Alpha ferrite. So alpha ferrite is the interstitial solid solution. It is it is the interstitial solid solution of carbon in alpha iron. And this alpha ferrite is simply can say the only ferrites. The microstructure, the crystal structure of alpha ferrite is the BCC. Crystal structure. And the ferrite, the word drive from a Latin word ferrum, means meaning of this word is iron. The maximum solid solubility of carbon, maximum solubility, maximum solubility of carbon in the alpha ferrite is 0.02% at 727 degrees centigrade, and it is less than 0.0005% at 20 degrees centigrade. At room temperature, it is 0.08%. This phase is the soft and ductile. This phase is the soft and ductile. So ductility of this phase is the higher as compared to the other phases like austenites and cementite. This is the ferromagnetism. This is the ferromagnetic. This is the ferromagnetic at less than 768 degrees centigrade. 768 degrees centigrade is the Curie temperature. So at Curie temperature is the temperature at which the magnetic properties are changed to the non-magnetic properties. So above this temperature, above this 768 degrees centigrade, the it change into the non-magnetic ferrite. Non-magnetic ferrite. So these are the some characteristic of the alpha ferrites. Now we will discuss the another phase. Uh, Another phase is we will discuss the austenite. What is the austenite? It is also the interstitial solution. It is also a interstitial solid solid solution of carbon in gamma iron. So it exists above 727 degrees centigrade for eutectoid steel containing the carbon percentage 0.77%. It is also soft and ductile, tough and malleable. Crystal structure of this phase is the FCC iron. FCC crystal structure यानी FCC में फेस centered cubic. Next, it has the maximum solid solubility of carbon is approx maximum percentage of carbon is 0.77% at the temperature 727 and 2.11% at 747 degrees centigrade. So it depends on the carbon. The carbon solubility of the carbon is decreases from the 2.1% with decreasing the temperature with decreasing the temperature. And it also depends on the carbon content and temperature. What is the volume of the austenite? So the region of the austenite increase and decrease with the temperature and carbon percentage. It also depends on greatly on the some austenitizer. This phase is the stable above this phase is the stable above the 727 degrees centigrade, and below this it convert into the ferrite and cementite. So next phase is delta ferrite. What is the delta ferrite? This exists at the higher temperature. Becomes the delta iron. It is also the interstitial solid. So it is the interstitial solid solution of carbon in delta iron. Delta iron. Maximum solubility is also varying. Maximum solubility of carbon 0.09% at 95 degrees centigrade. 95 degrees centigrade. It is the high temperature phase. And it is the high temperature manifestation of the alpha ferrite. High temperature manifestation high temperature manifestation of alpha ferrites. The magnetic properties are the paramagnetism. Magnetic properties are the paramagnetic properties. So next phase is the cementites. What is the next phase? Cementite. Cementite has the chemical formula Fe3C. It is also called the iron carbide. Crystal structure. Orthorhombic. It is the interstitial intermediate compound. Interstitial intermediate compound. The hardness of this phase is the BPN. Thousands BPN. So this orthorhombic structure contains the 12 iron atom and 4 carbon atom. Carbon atom. This phase is the brittle in the nature. So brittleness of this phase is the high, tensile strength is high, higher comparatively. This phase is the ferromagnetic phase is the ferromagnetic up to 210 degrees centigrade, and above 200 degrees centigrade it is the paramagnetic. Melting point of this phase is 1227 degrees centigrade. So these are the all phases and their characteristics you should remember, and so these are the very important, and the hardness, strength and properties, structures all are vary with the carbon percentage. So carbon percentage plays the very important role in important role to change the allotropy property and crystal structure of the iron. So the property of three phases like tensile strength of tensile strength in the meganewtons per meter square. For the ferrite is the 215, and hardness of the ferrite is also very low as compared to the cementite is VPN. Elongation percentage elongations for 5 centimeter is approx 15, and austenite, for the austenite the tensile strength is the thousands thousand tensile strength is the 1035 meganewtons per meter square. This is the tougher, and this has the higher toughness as compared higher tensile strength as compared to the ferrite and the cementites, and hardness is also the higher 395 ppm. So uh, very soft phase is the ferrite, and cementite has the 35 meganewtons per meter squares, and the hardness is the very high comparatively. So it is the very hard phase. It is also the harder. It is also the harder than martensites. We will discuss later about the martensites. And elongation we can say that 0%. So hopefully this video is the beneficial for you, and it is the knowledgeable for you. So please like and subscribe the channel, and you have any doubt you can write in the comment box. You can ask the question.